So the first thing we talk about is factoring. Factoring is one of the major topics in this class. The step for factoring is first, you need to see if they have anything in common and factor out the GCF. The GCF represents greatest common factor. So after you pull out a GCF, you can see if it's a 2 terms, 3 terms, or 4 terms type of factoring. They all use different techniques. And then you're going to start factoring. And after you factor it one time, you want to see if you can factor this again. So the first one, we're going to do something basic to warm up our factoring skills. So if any time you need to pause the videos and write down things, please do it. So first of all, we will follow the steps and see if there's anything in common. So I want to know if you can figure out how many terms we have here. Okay, so we have 2 terms, and look at both of them. Do they have anything in common? So it looks like both of them can be divided by 2, and both of them can be divided by 4. But 4 is going to be the greatest common factor. So we can pull 4 out, and both of them have x. The highest they have x in common is x to the first power. So after we pull out the common factor, we can see, and I'm going to use my finger coupling method, so I can put a 4 and 1 x, so I still have an x, right? And then I can bring down my addition sign. 8 divided by 4 is going to be 2, and after I pull out an x, I don't have any more, right? And if you want to double check this is correct, you can multiply back in, distribute 4x times x is 4x squared. 4x times 2 is 8x. So you can double check your answer. So this is one of the basic factoring problem. Let's look at another one. So again, if you need to stop the video and write it down, please do that. So this look a little bit longer. But basically, you still have just 2 big terms. And I hope you can see what they have in common. And it's going to be y minus 2. So we can pull out y minus 2 as my common factor. And after that, if I cover this, I see the first term still have 7x. And then the second term still have minus 2. And again, if I want to multiply back, I should get back to the questions, right? So we can double check the answer. So this is the very basic one. You pull out the GCF. So next, we're going to start with factoring with 2 terms. First, we are going to list the type that we have, including sum of 2 squares, and then we have difference of 2 squares, and we also have sum of 2 cubes and difference of 2 cubes. So anytime if you need to pause the videos and write down any information, please feel free to do so. It's important for you to take the notes and organize your notes and use it to study for homework and exam and quizzes. What do we mean by sum? Additions. And difference? Subtraction. And square mean you have 2 perfect square. Cube means you have 2 perfect cubes. So this is just the question, right? How do we factor them? Anybody remember any of this? The second one is very popular. So you will see that a lot. You will see it on the competency exam also. Anybody know how to factor difference of 2 squared? So the way I remember is I'm going to write this down without the square. They look like twins. So one is a minus b, one is a plus b. And you can also do a plus b times a minus b. The order doesn't matter because it's multiplication. Are we okay with that? How about sum of two squares? So sum of two squares is actually not factorable, so we call this prime. At this moment, we say it's not factorable, but later on in college algebra, they say you can factor it, but it comes with I. And what is I?
Imaginary.
Imaginary number. So it's not factorable with real numbers. It's only imaginary. But at this moment, you just can tell me like you cannot factor this. All right. So how about sum of 2 cubes and dividend of 2 cubes? Those are a little bit harder. So the way I remember it is, you look at this, and you write that down without the cube. Are we okay? Same guy without the cube. And then I have my sandwich. First term need to be square. Last term need to be square. And then the middle guy would be one of each. So AB. And then the sign is going to be SOAP. Soap. What do I mean by that? S is the same as the question. O is opposite, so instead of add, we have subtract. And the last one is AP. What do I mean by AP? AP means always positive. Okay. So using the same one, we're going to try to do the subtraction. Can you help me with that? So first of all, we need to write down without a cube, right? So what do we have? A minus B. And then the sandwich, right? So the first term need to be A square. The last term need to be B square. And the middle term would be one of each. So it's going to be AB. And the sign is SOAP, right? SOAP. So same with that, which we have. And opposite would be plus. And the last one is always positive. Are we okay? All right. So this is the first one with the two terms example. This is look like subtraction. Subtraction, we call that what? Sum or difference? Difference of two squares. So I want to make sure this is actually difference of two squares. Can you rewind 9x squared as a perfect square? What times what is 9? 3 times 3. And then x times x would be x squared, right? So 3x times 3x is 9x squared. Are we okay? Alright. How about 4y squared? We can put 2y in there, right? 2y times 2y is going to be 4y squared. So this is representing what we talked about earlier, a squared minus b squared, which is a plus b, a minus b. I told you the order doesn't matter, right? So my a is kind of the 3x, my b is kind of the 2y, right? So basically, to factor them, I just need the first term plus the second term, the first term minus the second term, right? So what do I put there? 3x, plus 2y, and then 3x minus 2y. So once you rewrite them as perfect square, subtract another perfect square, it makes things a little bit easier, right? Are we okay with this? So it looks kind of easy, and then most of you can follow this, but you have to go home and practice a little bit before you can apply it on your own. So understand it's like a little bit lower level, but application would be a little bit higher level. So we require a little bit practice. Okay, question on this. Let's do one more. We're going to practice factoring. This is a little bit harder. 125 cube square minus n cube cube square. So this look like difference, right? Is it different of 2 square or different of 2 cube? I heard 2 square. But I also have this guy here. Cube. Do they have anything in common? Yeah. What is it? The cube square, right? So we pull out the cube square. It's gonna hang out there for a little bit. After I pull out the cube square, like I pull out this one, I still have 125 minus, I pull that out, I have n cube. Okay, so now it look more like different of 2 cube. Okay, but I need to rewrite them as a perfect cube to make sure this is actually some cube minus some other cube, right? What cube make 125? 5. I can double check that. So 5 times 25 is 125, and then 5 times 5, right? So I can see 125 is actually 5 to the 3rd power. And then what cube make n cube? N. Okay. All right. So we're going to need to apply what we learned earlier, right? So take a deep breath. We're going to be able to do it. I need to first write this down without a cube, right? So what do I have? 5 minus n, I heard. Very good. And then the sandwich, the first term need to be, use that and do what? 5. Huh? Yes, but like the 5 need to do what to it? Square, okay. And the last term need to be n raised to the 2nd power. The middle guy is going to be 1 of each, so 5n. And like you say, the sign is going to be SOAP, SOAP, right? So same as the question, and then opposite as the questions, and the last one is always positive. So the only thing else we need to do is change the 5 squared to 25. So 25 plus 5n plus n squared. Are we okay? So this one is a little bit more complex. It may require a little bit of practice. Questions? Strategy. Strategy to factor 4 terms, we need to factor by start with a G. Grouping, thank you. So I would say grouping in pairs. Alright, so if we are factoring 6x cubed plus 3x squared plus 8x plus 4. We have 4 terms here, right? And we want to do factor by grouping, which means I do 2 at a time. And if we do 2 at a time, what do they have in common for the first 2 terms? Both of them can be divided by 3, and both of them have x raised to 2nd power. That's correct. And then after I pull that out, 6 divided by 3 is 2. I pull out 2 out of 3, so I still have x. I bring down the plus sign. Okay, this is the problem. So I pull out everything, right? Can I leave it blank? No, because if I multiply this with this, I got the first term, right? If I leave this blank, I lost the 2nd term. So that's not okay. What should I put here so I can multiply this and get back to 1? 1, very good. So this is one of the common mistakes. Make sure you hold that with a 1. So 1 times this get me the 2nd term. Are we okay? Yeah. All right, the second pair, what do they have in common? 4. Yes, so we bring down the plus sign. Both of them can be divided by 4. So after I pull out a 4, 8 divided by 4 is 2. I still have my x. Bring down plus. I pull out the whole 4, so I need to put a 1 to hold the place. Are we okay? So now they have this in common, right? So if they don't have the same here, probably you did something wrong, okay? So they have this common factor. We can pull that out. 2x plus 1. And then we also have this guy, so which is 3x squared plus 4. Is that our final answer? Yes. This is checking. So this is a perfect square, right? 4 is a perfect square. How about 3 squared? Is it a perfect square? No. And even if this is a perfect square, this is sum, right? Sum of 2 squared is not anything anyway. So, but we need to check. So this is our final answer. Any question about factor by grouping? And because factor by grouping seems to be okay method for most students, so they want to factor the 3 terms like that. So we're going to show you the next one is 3 times.